Today's topic is rational problem solving. In this video we're going to look at how to apply rational equations to solve real-world problems. So I'm going to do half of the problems in the packet and you will need to complete the other half on your own. I've written the numbers you need to complete up top. It's 4, 5, 7, 9, 11, and 12. So number 1 says that Shelley can paint a fence in 8 hours. Karen can do it in 4 hours. How long will it take them to do the job if they work together? So in these types of problems, what you're going to want to do is compare their individual rates and the combined rate. And the individual rates should add up to the combined rate, and that will give us our equation to solve these problems. So let's define our variable first. In this case, we are looking for the time it will take them to do the job together, so we'll say that that's t. T is the time in hours. So let's look first at Shelley's rate. We know that Shelley can paint the fence in 8 hours, so her hourly rate is that she can paint 1/8 of the fence in an hour. Karen says she can do it in 4 hours, so we know she can paint 1/4 of the fence in an hour. Their combined rate is that they can paint 1/x amount of the fence in 1 hour. So we can take Shelley's rate and add Karen's rate to get the combined rate. Sorry, I wrote x. I should have written t down here. So now we have a rational equation that we can solve based on what you've already learned. So 8t will be our least common denominator. We'll multiply that through to get t plus 2t is equal to 8. So 3t is equal to 8, which means t equals 8/3. So for our final answer, 8/3 doesn't make a lot of sense when we're talking about the time to paint a fence, so we will change that to a mixed number. So it will take them 2 2/3 hours to paint the fence together. Okay, there's your final answer. Number 2 says that Tim can stuff envelopes 3 times as fast as his daughter Georgia. They have to stuff 5,000 envelopes for a fundraiser. Working together, Tim and Georgia can complete the job in about 4 hours. How many hours would it take each of them working alone? So here's the reverse situation of what we saw in number 1. We know the combined rate and time. We need to figure out the individual time. So let's use x as our variable here, and we'll say that x is the time for Tim to stuff the envelopes. So Tim's rate, if he has to stuff 5,000 envelopes, and the time is x hours, then his rate is 5,000 divided by x, and that will tell us how many envelopes he can stuff in 1 hour. Georgia, we know it takes her 3 times as long. Tim stuffs 3 times faster, so it takes Georgia 3x is the time for her, so 3 times as long. 5,000 divided by 3x, and that's her hourly rate. That tells us how many envelopes she can stuff in 1 hour. So combined, we have 5,000 stuffed in 4 hours. So if we divide that by 4, we find out how many envelopes can get stuffed by the 2 of them in each hour. Now that we have our 3 rates, we can say that Tim's rate plus Georgia's rate is equal to the combined rate. I'll go ahead and reduce this to 1250. That's what it divides to. And then solve the rational equation. 3x is our common denominator. So we have 15,000 plus 5,000 is equal to 3,750x. We end up, as you simplify this, getting 20,000 divided by 3750 is equal to x. And that will reduce to 16 over 3. So our x we had designated as the time for Tim to stuff the envelopes. So Tim can stuff the envelopes individually, and we'll convert this to a mixed number, in 5 1/3 hours. Georgia takes 3 times as long, so we're just going to multiply that time by 3. 3 divided by 3 is 1, so we end up with 16 hours for Georgia. And that's our final answer. In number 3, we change gears a little bit and start looking at distance, rate, and time. This takes advantage of a formula that you should be familiar with. The distance equals rate times time. So let's take a look at the question. Rosa can jog 5 miles downhill in the same time it takes her to jog 3 miles uphill. She jogs downhill 4 miles an hour faster than she jogs uphill. Find her jogging rate each way. For these problems where we're talking about distance, rate, and time, I recommend setting up a table just like this one. It will help you to analyze each piece of the equation that you need to put together. So the distance uphill, it says that she can jog 3 miles uphill. Downhill, 5 miles. So our rate, she jogs downhill 5 miles an hour faster than she jogs uphill. So our variable we're going to say is x is the rate to jog uphill. That means that downhill she's jogging at a rate of x plus 4 because she's 4 miles an hour faster. Time, in this column what you're going to do is just rearrange this formula to say time equals distance divided by rate. And that's what's going to go over here. So our distance uphill is 3 and our rate is x, so 3 over x. Downhill, we're going to have 5 divided by x plus 4. And it says that she can jog these two distances in the same amount of time. The equation here is 3 over x is equal to 5 over x plus 4. So now we have a rational equation that we can solve. We'll clear the denominators by multiplying by x times x plus 4, which gives us 3x plus 12 is equal to 5x. So 12 is equal to 2x, and 6 is equal to x. X we decided was the rate to jog uphill. So her jogging rate uphill is 6 miles per hour, and downhill it is 10 miles per hour. Because downhill the rate is x plus 4, so 6 plus 4 is 10. Number 4 you will go ahead and complete on your own, as well as number 5. Those are similar problems, so set up a table just like I did on number 4 and go ahead and solve those. Number 6, we start looking at ratios. So here we have a college basketball player who has made 58 out of 82 attempted free throws this season. So the initial ratio is going to be 58 out of 82. We want to know how many additional free throws she must make in a row to raise her free throw percentage to 90. So x is going going to be free throw attempts. So to rewrite this ratio, we want to look for how many more shots she needs to take, and in this case how many she has to make. So the number she makes will be the same as how many she takes because of what the problem is asking. How many additional free throws must she make in a row to raise her free throw percentage? So this becomes our new ratio, and the equation is going to be 58 plus x divided by 82 plus x is equal to 90%, because we want an overall percentage of 90. So we have our rational equation. We'll go ahead and simplify on the right first, reduce this to 9/10, and then multiply by our common denominator of 10 times x plus 82. This will multiply out to give us 580 plus 10x is equal to 9x plus 738, I believe is what that multiplies out to. Yes, 738. So now we'll solve for x. X equals 158. So she must make 158 free throws. That's a lot to make in a row, but that's what she's going to have to do to get her percentage up to 90. Number 8. So this problem says that we are planning a school field trip to a local theater. It costs $60 to rent the bus. Each theater ticket costs $5.50. This is similar to a problem that you saw in your applications exit ticket a couple weeks ago. We're actually going to look at the function this time. So here we want to write a function c of x to represent the cost per student if x students sign up. So c of x will be our function. The cost per student is going to be the $60 to rent the bus plus the $5.50 per student. So if x is our number of students, then the cost of the tickets will be $5.50 times x. And we're going to divide this because we want to find the cost per student, so we're looking for an average. We'll divide it by the total number of students. So now we have our function. We can go ahead and do b. How many students must sign up if the cost is to be no more than $10 per student? So no more than, that tells us we have an inequality. The cost is $10 per student, so we're going to replace c of x with 10. And $10 will be greater than or equal to 60 plus 5.50x divided by x, because this cost must be less than or equal to $10 per student. So to solve this, we want to first find our critical numbers. We start with our undefined values, which are x equals 0. And then our intersection points. The intersection point is where 10 equals 60 plus 550x divided by x. So we'll have 10x equals 60 plus 550x. Subtracting that 550, we end up with 450. X equals 60. So x equals 13.3. So these are the critical numbers. If we want to look at a number line, we can put that on here as 0, 13.3. We don't need to test a number over here to the left of 0 because we're talking about a number of students. We're not going to have fewer than 0 students. So we don't need to test the left side. That 0 is the asymptote. The 13.3 is our solid intersection point. So let's test a value 1 here and 14 here. If x equals 1, we'll have 60. Sorry, that's 10 is greater than or equal to 60 plus 550 times 1 divided by 1. So that means 10 is greater than or equal to 65.5, and that's not true. So we'll look at 14. If x equals 14, then you can do the math on your own, but this one comes out to 10 is greater than or equal to 9.79. Is that true? Yes. So we know that x has to be greater than or equal to 13.3. But students do not come in thirds. You have to have a whole student, so the students that must sign up is 14. So 14 students must sign up. Okay, we have just one last problem to look at, and that's number 10. Here Jason drove 50 miles at a speed of x and then increased his speed to 10 miles per hour for the next 100 miles. The entire trip took him 10 hours. How fast was he going on each part of the trip? So here we're back to distance, rate, and time. So I've set up a table here. At the beginning, his distance was 50 miles first, and then he finished having gone 100 miles. It's already given that his speed is x at the beginning, so the rate will be x, and then he increased his speed to 10 miles per hour. Increased his speed by 10 miles an hour, so it will be x plus 10. The time it took was 10 hours, but remember t equals d over r. So for our time, we're going to say 50 over x at the beginning and 100 over x plus 10 at the end. So our equation is going to be 50 divided by x plus 100 divided by x plus 10 is equal to 10 hours because it took 10 hours total. We'll just solve this rational equation. Multiplying x times x plus 10, we get 50x plus 500 plus 100x is equal to 10x squared plus 100x. So I'll move everything to the same side. We have 150x. First I'll write this 10x squared. So 150x is being subtracted. We end up with negative 50x, and then 500 is being subtracted, so we get minus 500. We can factor out this 10. And then factor further to get x minus 10 and x plus 5. So this means the possibilities are that x could be 10 or negative 5. But notice that the negative solution isn't going to work because this is means we have a negative rate of speed, and that is certainly not the case. So we can get rid of negative 5. So that means the rate at the beginning was 10 miles per hour. And at the end he sped up to 20 miles an hour. So that's it for solving rational problems. Go ahead and complete the other 6 problems so that we can discuss those in class.